Hello students, how are you? I hope you are doing well. I have come back again with a video. This time I have picked questions from Mechanics 2023 NEET exam. So let us discuss them one by one. Students, the questions are in sequence, okay? The first six questions have already been discussed in the first video. You can kindly look back into that, okay? Question number 7. A bullet from a gun is fired into a rectangular wooden block with velocity u. When bullet travels 24 cm through the block along its length horizontally, velocity of the bullet becomes u by 3. Then it further penetrates into the block in the same direction before coming to rest exactly at the other end of the block. The total length of the block is. Now students, this very common question, these kind of questions have been frequently asked in different exams. So there is nothing new. But anyway, I will derive a simple formula for you, and then straight away you can memorize that formula and apply this in this question. Okay, right. So let us start deriving the formula. So here you have a block, let us say of length L, which we have to find. The bullet enters the block with an initial speed u. Over a certain period of time, let us say its velocity reduces to v. Assuming uniform retardation, that is assuming uniform negative acceleration, this is the assumption, underlying assumption in this question, and we can use this formula v square equal to u square plus 2as. Since acceleration is assumed to be constant, we are entitled to use the equations of motion. So therefore we have v square is equal to u square minus 2a into L dash, or I can write 2a L dash is equal to v square minus u square. Okay, this is equation 1. Then considering the entire motion from beginning till the end, as it is given that it stops towards the end of the block. Then considering the entire motion, I can write 2al is equal to u square. So here it is u square minus v square. This you can number it as equation 2. Now when you divide equation 2 by 1, you will get L dash by L is equal to u square minus v square. Divide this to get like this, 1 minus v by u whole square. So this is a very handy formula. Okay? It comes very handy in solving these kind of questions. So you can always memorize this formula. Now applying this to this formula, we have L dash 24 cm upon L we have to find. You have 1 minus V is u by 3, u is u itself. So u by 3 by u is this. So this will be 1 minus 1 by 9, that is 8 by 9. So cross multiplying, you get L is equal to 24 cm into 9 by 8. So this is 27 centimeters. So correct option is the fourth option. 8 3s are 3 9s. I hope that is clear, students. Let us move to the next question. The potential energy of a spring when stretched by 2 cm is u. The spring is stretched by 8 cm, potential energy is stored in it. Now students, we all know that the spring potential energy or the elastic potential energy present in a compressed or stretched spring is this. As you can see, for the same spring, the stored potential energy will directly be proportional to square of the elongation or compression. Now I am just going to find the factor of change for u, okay, by knowing the factor of change of x. Now see, initial x was 2, final x is 8. So factor of change for x is how much? 8 by 2. Okay. Keep the operator as it is if it is there. So you can see that the factor of change for u is 16. That is new value will be 16 times the initial value. New value will be 16 times the initial value. So correct option is the third option. Then moving on to the next question. Question number 9. Two bodies of mass m and 9m are placed at a distance r. The gravitational potential on the line joining the bodies, where the gravitational field equals 0. Again, students, I am going to derive a simple formula here for the position where gravitational field is 0, and then immediately we can solve the question. Alright. So let us say that this is the separation is r. You have one spherical body of mass m1 and the other spherical body of mass m2 separated by distance r. Now let us say this is the point where the gravitational field intensity is 0. Let us say this distance is r1 and this distance is r2. Now field due to m1 will be in this direction. Let us say I1, whereas field due to M2 will be in this direction. Let us call it as I2. Since Ig is 0, we can write I1 is equal to I2. Because when the gravitational fields due to both the point masses or both the spherical bodies cancel each other, only then you get equal to 0. So they should be opposite and equal. So numeric value can be equated. So I1 will be G m1 by r1 square, whereas I2 is G m2 by r2 square. So I can write that extracting the square root, I can write r1 by r2 is equal to root m1 by root m2. And also at the same time, considering the entire distance between the two particles, I can write r1 plus r2 is equal to r. If we solve these two, then we'll get r1 is equal to under root m1 upon root m1 plus root m2 into r, and r2 will be root m2 upon root m1 plus root m2 into r. So my sincere suggestion will be to memorize these results. In order to save time, you should always have these results in your fingertips. So that means now we can easily calculate the gravitational potential there. So we have to calculate the gravitational potential here at this point. So I can write gravitational potential total will be potential due to the first body plus potential due to the second body. Remember, potential is a scalar quantity. You need to add them algebraically, that's all. So for the first, due to first one it is minus G m1 by r1, and due to the other it is minus G m2 by r2. Remember, gravitational potential is always negative because gravitational force is always attractive in nature. So here, let us calculate r1 and r2. So r1 will be how much in this situation? M and 9m. So this you have 1 upon 1 plus 3 into r, that is r by 4, and r2 will be r minus r by 4, that is 3r by 4. So when you substitute here, upon substituting, you have minus g m by r1. r1 is r by 4, and here minus g 9m by 3r by 4. 4 gm by r and minus 12 gm by r. So we have minus 16 gm by r. So correct option is the second option. Then moving on to the next question. A satellite is orbiting just above the surface of the earth with period t. If d is the density of the earth and g is the universal gravitational constant, the quantity is. Now students, this question you have to correlate this with Kepler's second law. What does Kepler's second law state? Kepler's second law, sorry, Kepler's third law, I'm sorry, students. Kepler's third law states that T square is proportional to R cube. The time period of the satellite is proportional to the square of cube of radius. So T square is proportional to R cube. Now, if we derive this formula, we can simply derive this formula. Now, what is time period? Time period is the distance traveled by speed. Let us say the orbital speed of the satellite is v, and it orbits around a planet along a circular orbit of radius r. Then, now orbital speed can be obtained by this. In order to go along a circular path, the necessary centripetal force required is provided by the gravitational pull. So the gravitational pull between the satellite and the planet is this. This gives the required centripetal force. So from here you can find V as under root gm by r. So if you substitute here as under root gm by r, so this becomes 2 pi upon root gm into r to the power 3 by 2. So this is the Kepler's third law. Now if you see, you can correlate this with this. Okay, T square. So let us square both sides so that we can write T square as 4 pi square by gm into r cube. Okay, Kepler's third law. This is Kepler's third law. Now in this situation, let us take this, let us substitute the value of mass as volume into density, because they have mentioned density as d. So let us replace m with 4 by 3 pi r cube. So you'll see that r cube gets cancelled, and sorry, instead of rho they have given it as d. I'm sorry. So you are left with this 3 and 1 pi gets cancelled here. So 3 pi by gd, you are left with 3 pi by gd. So it is proportional to t square. Okay. So correct option is t square. Then moving on to the next question. The ratio of radius of gyration of a solid sphere of mass m and radius r about its own axis to the radius of gyration of a thin oval sphere. So you have a solid sphere and a hollow sphere of the same mass and same radius. So for a solid sphere, the moment of inertia will be m k1 square, where k1 is the radius of gyration. It is equal to 2 by 5 mr square. So therefore k1 is under root 2 by 5 into r. Gets cancelled here. Similarly, shell, for the shell, the moment of inertia is again m k2 square. I'll take it as, where k2 is the radius of gyration. It is equal to 2 by 3 mr square. So therefore, the radius of gyration is under root 2 by 3 r. So if you Get the ratio K1 by K2. K1 by K2 will be root 2 by root 5 into root 3 by root 2. So root 2 gets cancelled. We are left with root 3 by root 5. That's all in this video, students. Thank you for watching. Kindly subscribe to my channel and hit the like button. Thank you.